Next, we are welcoming Eden Winslow.
Everyone, if you can, I want you to lift your hands in front of you and just wiggle your fingers like this. Great, and then make a fist. And lastly, do a pinch. Awesome, you can lower your hands, thank you. Now, what most of you just did with very little thought is actually incredibly complex from an engineering, neuroscience, and prosthetics perspective. In order to move our hands and our fingers, our brain has to first form an image, a plan of what it wants to do. Then it sends signals down the nerves into the muscles in the forearm, which flex to move your hands. Prosthetic limbs hinge on the assumption that all of these pathways are still intact, which is known to be true for someone who developed a hand and lost it later in life. We can use sensors and machine learning techniques to read the electrical signals in the remaining muscles and control a robotic hand to do whatever grasp the person wants. But what about children who were born without their hand? Do they still have a picture of the missing hand in their brain? Can they send signals down to control a body part that never developed? It's historically been assumed not, which has severely limited the accessibility of high-tech options for children, leaving them almost exclusively with just an open-closed prosthetic hand. But the reality is that no one has studied this population in depth before. So, my research the past 4 years has involved traveling to children's hospitals around the country, working with kids as young as 5 years old who were born without a hand. I put sensors on their arms, as many as can fit, and ask, hey, can you imagine moving your arm into a fist? Can you imagine moving your arm into a pinch? And then taking it a step further, can you imagine moving your arm halfway to a fist? Can you imagine squeezing very hard and then squeezing very soft? I'm trying to figure out, do children born without a hand have the same capabilities with their brain and their muscles as someone who lost a limb later in life? And they do. These children can imagine moving a hand they have never had and produce at least 10 unique hand movements with their muscles. They can change the level of closure and the level of force they want to use. We even see evidence that their muscle dexterity improves with age at a similar rate as typical motor development. This has profound implications for the care that thousands of children receive. We still have some unanswered questions, like what is going on in a kid's brain when they're moving a hand that's not there? But in showing these kids are incredibly capable, we're already changing the narrative of the field, proving they have the innate ability to use advanced devices. Which means that one day, all of the advanced functions currently available just to adults, like making whatever grasp they want, can also be made accessible to pediatrics. So, the next time you give a fist bump or are debating how to make a heart with your hands, remember that our hands are pretty complicated, but even being born without them doesn't need to hold a person back.